resistance, and node A connects to the node B via 6 ohm resistor. Node A connects to ground via 12 ohm resistor, and node B connects to ground via 8 ohm resistor. Ground is reference. This is the problem statement. Now just I will be drawing a circuit diagram directly. From there we will apply the node analysis and we will solve the problem. In circuit diagram, 24 volt supply is already given, 4 ohm resistor, 6 ohm resistor, 12 ohm resistor and 8 ohm resistor. 8 ohm resistor. Now we have to first mark the nodes A and B. Now what you will be doing is you have to calculate the KCL. By using KCL we will calculate for node A and node B. Now what we have to do is just apply KCL at node A. When we apply KCL at node A, now I will just draw for the node A what actually it will be. The current summation of I entering is equal to summation of I leaving the node A. Now we will simply draw a diagram where we will be showing these all things. Now at node A, resistors are 4, 6, 12. This is node B, resistor is 8. Now as we are applying the KCL, just say each and every current is flowing away from the node A. Now we will write the equation for this. As no current is entering, as we assume all currents leaving the node A, summation of I entering will be 0 in this case. Hence 0 is equal to the leaving current. First current will be VA minus 24 divided by 4 for 4 ohm limb. You can say limb or element. Now plus, now what we are doing, as summation of entering is 0, that's why I have showed here 0. Now what I am doing, summation of I leaving, all these currents are leaving, hence we are adding them. Now if you look after 6 ohm resistor, we will get as VA minus VB divided by 6 plus, now as this is connected to ground, VA minus this 0 potential divided by 12 This is the equation which we have to solve for node A. Now what we have to do is we have to calculate it for same base, you can say. By calculating you will get by multiplying 12 to both the sides, multiply by 12 to all the equation, multiply by 12 to get VA here. Just what I will do is 12 into VA minus 24 divided by 4 plus 12 into VA minus VB divided by 6. Here also we are multiplying 0 into 12 plus 12 into VA upon 12. Now what you will get as these two will get cancelled, this will be nothing but 2, this will be nothing but 3, and 0 into 12 is 0, you know that. Now 0 equal to 3 VA minus 72 plus 2 VA minus 2 VB plus VA. Now by solving this 3 VA, 2 VA and VA, it will become 6 VA. 6 VA minus 2 VB. This 72. This is the final equation for node A. Now when we apply KCL at node B. When we apply KCL at node B, we will calculate in the same manner. First we will draw the circuit diagram for it. Six, 12, 4, 24 and 8. Now as we are applying at node B, the same way we will assume all currents are flowing away from the VB. Now current entering, summation of I entering is equal to summation of I leaving. In same way, the current entering will be 0 as no current is entering at node B. Hence, this will be 0 is equal to current leaving will be VB minus VA divided by 6 ohm resistor plus VB divided by this 8 ohm resistor. As B is not connected to 12 ohm resistor, this will not come. Only 2 resistors are connected to the node point B. Now solving this, we will get as 8 VB minus VA plus 6 VB 48 into 0. By solving this, just the cross multiplication we have did. Now 0 8 VB minus 8 VA plus 6 VB minus 8 VA plus 14 VB is equal to 0. This is the second equation. This is the first equation. Now what we will do? Now we will be just solving for this. Actually, we will be solving the equations V2. Yes, the same thing we are doing. Now, as the V and VB are nothing but V1 and V2 also, you can say it as node 1 and this as node 2 also. In some books they have given this problem as V1 and V2 nodes, that's why we are getting it. Now what you will be doing, the V2, I think some other way will apply. Yeah, it is correct. For reduce the same. Okay. Now what we will do, we will reduce just to divide by 2. 0 is equal to minus 4 VA plus 7 VB. This is the final equation for 2. Now what we have to do, just write these two equations one below the other. The first equation is 6 VA minus 2 VB is equal to 72. This is the first equation, and in this equation what you will do is 4 VA plus 7 VB equal to 0. This is second equation, this is first equation. Now even you can reduce it by dividing by 2. The first equation will become as 3 VA minus VB is equal to 36. This will be the first equation and this will be the second equation equal to 0. Now what you have to do is solve these two equations. How to solve these two equations and find out the VA and VB, we will look after that. Now by determinant method, delta, first we have to calculate the delta. Delta is nothing but 3 minus 4 minus 1 and minus 7. 3 minus 4 minus 1 and minus 7. This already you have studied up to 10th standard also, in first year diploma in mathematics 1 subject also you have gone through this. Now the determinant is nothing but minus 21 minus 4, it will be minus 25. Now delta 1 will be just replacing the first two values with these rest two values. means 3 6 and 0, and here other values will be same for b, as we are calculating delta 1. Delta 1 is nothing but it will be helpful for calculating VA in this case. Now 36 into 7, you can say 252 minus 0. If you calculate VA will be nothing but 252 divided by 25. You will be getting as VA equal to delta 1 divided by delta is nothing but 252 divided by minus 25. Let's see. This is also minus value. This will be minus. This will be minus. You will get answer as 14.82 volts. In the same way, you have to calculate delta 2. Delta 2 will be just 3 minus 4, 3, 6 and 0. Here we will get as 0 minus of minus 36 means plus 36 into minus 4. By solving this, just we will solve this. It is coming as 144. Delta 2 divided by delta minus of minus will be plus, and as the delta here is coming as negative 2, that's why the answer will be in negative 144 divided by minus 25. You will be getting it as 8.47 volts. Same way you calculate all these things, you will get VA VB is nothing but you can say V1 and V2 also. Just write it carefully, you will get through it. Now next we will be solving one mesh analysis problem. We will be solving a mesh analysis problem. Mesh analysis problem is given as